Hello, everyone. Welcome. I thought today I would spend a few moments talking about this week's lesson, Chapter 2, which is primarily on on primitive data types in Java. Now, there are two categories of data in Java. There are the primitive types, which we are primarily studying this week. And there are what are called reference types, and those will be the objects. They will be the topic of roughly the last 40% of the course. And we'll be writing our own object types, if you will, and creating objects that are instances of things that we have written. So that's when we start getting into the fun things. But this week, as I said, there are two categories of data in Java. There are the primitives and the reference types, or the object types. And think of the word data type in the same sense that we would say that an apple is a type of fruit, or an orange is a type of fruit, or pickups and sedans are types of vehicles. An int is a type of data. In fact, it's a type of numeric data. A double is a type of data, and again, it is a numeric data. Now, these primitive types all start with a lower letter. By the way, section 2.8 in this lesson talks about naming conventions. They will be enforced, okay? But all the primitive types start with a lowercase letter by convention. All the reference types or objects start with an uppercase letter. And so if I have, and let me see if I can share my screen here. There we go, that's good enough. And so if I have an int, that is going to be a built-in type. Double is another primitive built-in type. And they all start with lowercase letters. They are built in to the language. String is a reference type, it's an object. Now, string is kind of strange. It starts with an uppercase letter, which is by convention means that it's a reference type, but it's kind of half in and half out of the language. There are things like for int, there is a corresponding type integer, and for double, the primitive type, there's a corresponding type double. You can see the case difference of the first letter. Integer with a capital I, double with a capital D are reference types. They are objects. They are related to their associated primitive type. We'll get into those a little bit later. The point I want to make now is don't confuse this double with this double, okay? For the moment, just always use the lowercase d, because the uppercase D is something for when you need it, and you have to know the conditions under which you need it. Now, string, as I said, is kind of half in and half out of the language. It's a reference type. It's technically not part of Java, but I can have literal strings like that, which the compiler understands and handles for me under the covers. So it is, as I said, just kind of half in and half out of the language. One thing I want you to understand are the various sizes of the primitive data. So for instance, int is 4 bytes. A double is 8 bytes. And those sizes of the data, especially when we're talking about an int, which limit the values you can put in there, because eventually you just run out of bits. The floating point types of Java, double and float, are stored in something akin to scientific notation. So we have a fixed number of bits for the significant bits for the mantissa. Those are the significant bits. There are a fixed number of bits for the exponent. And just like scientific notation would be written, might be written something like, well, I'll do it down here. 1.234 times 10 to the 10th to the 8th power. And I can't do that in Notepad, sorry. But that is how it's stored. The 1.1234 are stored, and the 8 for the exponent is stored. Now, what this means is, one implication is it has a lot of digits for the precision, for the significant digits, but they're not infinite. It is limited. Now, our mathematical concept of a real number has an infinite number of digits out to the right of the decimal, but we don't have an infinite number of digits out to the right of the decimal. So we have to approximate those real numbers like the square root of 2. And that approximation, whenever you say the word approximation, you're introducing error. And hopefully in this course, we'll be able to show you some of that, especially when we get to arrays. But that error is why you should not do math.sqrt 2.0 and times math.sqrt 2.0. You should not do this test, because that test may well fail. And it's because one of those significant digits way down at the end will not be exactly what you want. And so never test floating point numbers for equality like that. The worst thing about this is that when you test your program, that will work. When I test your program, it won't. And so your program will fail. Now, as I said earlier, Java has naming conventions in section 2.8. One of the most common statements I make to students in this course is, look at section 2.8, because they get the naming conventions wrong. Amazingly enough, Java programmers really do adhere to those naming conventions. I've never seen another language like it. Also in this book, you'll be reading about JShell. Now, that's just mostly there for your information. We won't be using it any further in the course, but it is good to know. Another comment about Java. Java is not an ASCII language. When we're representing characters in Java, when I look at this hello world up here, those are not ASCII characters, representations inside Java language, inside the Java language. Java is a Unicode language. The major difference between ASCII and Unicode is that ASCII is only a 7-bit representation. It can really only handle the Latin characters. Unicode is 16 bits of representation, and it can handle non-Latin characters like Greek and I think Japanese as well. So this is a favorite question of evil Java programming instructors. Is Java an ASCII language? The answer is no. For the increment and decrement operators, when writing your programs, I suggest keeping them very simple and standalone. So for instance, if I have int I equal to something, and I want to increment it, that's fine, but don't try putting those increment or decrement operators in a more complicated expression. There are some subtleties going on, and again, it will break exactly when you don't expect it to break, and it will be extremely difficult for you to figure out. Now, Java is a safe language, and one of the aspects of it being a safe language is it is what is referred to as a strongly typed language. Remember, type, like the data type I was speaking of earlier, that's the same usage of the word type. A strongly typed language means that I can look at a piece of Java code and I can determine the data type of every expression in that code just by looking at the code. I don't have to execute anything. Now, some of you coming from a Python background will notice that this is not the way other languages, especially Python, work. In Python, it is referred to as dynamically typed. Java is not that way. I can look at the code. I don't have to execute anything. I can just look at the code and tell what type every expression is in that piece of code. Now, this gets into data conversions. Again, Java is a safe language. So if I have a double character and I have an int, or if I have a double variable and an int variable, I can do conversions such as this. Under the covers, Java will do them for me. And why is that? That's because an int has no fractional portion. A double can have a fractional portion, but the fractional portion may be 0. And so it's always safe for me to assign an int value into a double. However, the reverse is not true. I cannot say int equal d because the compiler says that double variable might have, that double value might have a fractional portion to it, and you would lose that when you assign it to an int. So Java's not going to let me do that. What I have to do is explicitly cast. So I would have to say now, explicit casting is a promise by the programmer to Java. It says, "Dear Mr. Java, I know that this looks unsafe, but trust me, I also happen to know that in my program, in my usage of it right here, this is going to be a safe thing to do." And so that's what happens. That's how you cast, or that's how you convert floating point representations like a double into an int variable. By the way, these implicit casts that Java will do for us are referred to as widening. The explicit cast that we have to do, tell Java to do, whether it wants to or not, is referred to as narrowing. So that's another thing to be aware of, especially for you Python people. So those are most of the things that I think are really sort of base level. This is where we're building on for this chapter. If you have any questions, please let me know. We can do remote meetings and so forth in lieu of office hours. So hope things go well, and be talking to you later. Bye.